Dear learners, welcome back to Engines and Transmission Systems. We are today going to see the third model, that is supercharger, turbocharger, lubrication and cooling system, which is a subsystems of engines. So once again, I am Dr. R. Venkatachalam, Professor, KSR College of Engineering. I welcome you all for this wonderful session. Our content today I am going to present is supercharging, types of superchargers, turbochargers, intercooler, variable geometry turbocharger, E-turbocharger, lubrication system, cooling system and conclusion. So let us start with introduction to supercharging. Supercharging is the process of increasing the intake pressure before the air enters into the engine cylinder to improve the engine power. So you can see the diagram. There is a compressor, then compressor fed the compressed air to the engine. That engine intake receives the air and it produces the power through the crankshaft that is connected to the driving transmission system. Here the compressor runs with the engine power. There is a shaft that drives the belt through the belt. Then the compressor receives the power. The compressor intakes the air from the atmosphere and compresses it. With high pressure it supplies to the cylinder inlet. This is how it functions. So different superchargers are there. One is positive displacement root supercharger, twin screw supercharger, then dynamic type centrifugal supercharger. So introduction to turbocharging. So in addition to the supercharger, a turbine is attached to the compressor shaft, so that will receive the power from the exhaust gases. So this is how it functions. Exhaust gas, you can see, refer this figure. This is the engine exhaust is marked in the orange, that is supplied to the turbine inlet that receives the power and that rotates the turbine. That turbine is coupled with the compressor. That compressor receives the power from the turbine and that turbine rotates the compressor. That compressor receives the air from the atmosphere and compresses the air and supply to the engine intake. So outtake is used to power the turbine. That turbine connects the compressor that rotates the compressor. That compressor provides the compressed air to the inlet valve that is inside the cylinder during the compression stroke. This is how the turbocharger works. So turbocharger that increases the engine's power by compressing the intake air using the energy of the exhaust gases. It improves the efficiency and fuel economy without increasing the engine size. So there is an intercooler which is required to cool the air from the turbocharger. So it increases the air density, then improves the combustion efficiency. So air to air types are there, then air to water types are there. You can use the water also to intercool the compressed air from the turbine. So variable geometry turbocharger, that is VGT. So it has a turbine function and also this geometry can be varied according to the speed of the air, so that it can effectively utilize the exhaust air to produce the power. That power will be used to run the compressor which is attached to the turbine. Ring of movable vans around the turbine wheel to adjust exhaust gas flow. At low engine speeds, the vans partially close, accelerating the exhaust to spool the turbo instantly and reduce lag. At high speeds, they open the wide to maximize airflow and prevent overboost, so that it can accordingly adjust its ring to close the vans as well as open the vans in order to match the requirement of the compressed air from the compressor. So electric turbocharger, e-turbocharger we can say. So it is an advanced turbocharging system that uses an electric motor to assist the turbocharger. It eliminates turbo lag by providing instant boost, especially at low engine speeds. So battery that powers the inverter, that inverter is used to run the motor that is coupled with the compressor, and also it can act as a generator also. Vice versa it can use. So exhaust gas from the engine is fed to the turbine. The turbine connects to the generator. That generator will function as a connect the compressor. It can act as a motor or generator. So air supply is given to the engine, that will function cyclically. So lubrication system is important to minimize the friction from the engine moving parts by supplying the lubricating oil on the moving parts to reduce the friction, minimize wear, remove heat and ensure smooth and efficient engine operations. So types of lubrication systems are splash lubrication, pressure lubrication, wet sump lubrication, dry sump lubrication systems. Then lubricant requirement, as a lubricant or oil which is used to minimize the friction is required proper viscosity, high flash point, oxidation resistance, good thermal stability is required. So to evacuate the heat which is excess in the engine by using the cooling system. The cooling system is one of the necessary systems that are present in the internal combustion engine to reduce the temperature of the components inside the engine. It also helps to reduce the wear and tear of the component. It helps also in the smooth functioning and long life of the components. The cooling system types are air-cooled engine cooling system and water-cooled engine cooling system. So in conclusion, supercharging, turbocharging, increasing engine power and improve volumetric efficiency by supplying compressed air to the engine. So it supports the engine functions smoothly and efficiently. So advanced technologies like intercoolers, VGT and e-turbochargers enhance engine performance and fuel efficiency. So lubricating system reduces friction, minimizes wear, removes heat and ensures smooth operation of engine components. The cooling system also essential in engines, IC engines, which maintains the optimum engine temperature, prevents overheating and improves engine reliability and service life. So this is how we are going to close this session today by concluding these points, and we will see in the next topics. Thanks for your time. Thanks for watching. Thanks to you all. Thank you.